This video will cover the Year 9 Pythagoras and Trigonometry preview test for applications. So these are the A and B level questions that you should expect to see. I'll put some time tags down the bottom. If you're following along with the practice test, you can just skip to the question numbers. Otherwise, I'll put a description with them so that you can find the sort of question you need help with.
In question one, we've got two problems here. We've got an unknown side and we've got an unknown angle. But then just to mix this up, because this is a B level question, they've also thrown algebra in. So for the guys who've done extended, you'll have seen this sort of thing before. And for the guys that haven't, this is how you do it. You just ignore that it's even there. So what we'll do is we might start with our unknown side. I've got three sides, so I can use Pythagoras, okay? I can also recognize that this one here is a right angle. I know it's going to be a right angle because all of these questions are based on right angle triangles, okay? So what we'll do is we'll run our formula a squared equals c squared minus b. Wow, that's a really funny two. Let's try that again. C squared minus b squared, okay? And so we'd be calling this one C because it's the hypotenuse. We'll call this one A because it's the one that we're trying to find. And we'll also find this one will be B. Let's sub in and see what we can do with it. So we'll go in with A squared. So we've got 30 minus x all squared equals 29 squared minus 20 squared. And at this stage, I don't want those brackets falling apart, okay? I want to just keep all of that together. I'm not going to try and do anything too fancy here. You'll see what I mean. Just keep it together and pretend that 30 minus x is just one number, something that we don't know. Then what we need is we need 29 squared, which is 841. And we're going to take away 20 squared, which is 400, which means we've still got 30 minus x over here, and we've got 441 over here. Now we're not breaking our process. What we're going to do is we're going to square root both sides. Okay, so we'll square root both sides, and that's to get rid of this little squared here. And what I've got now on this side is 30 minus x because we've got rid of the squared, and on this side the square root of 441 is 21. And now what I would like to do is I would like to just keep going with my balance method. I'll take 30 from both sides. I'll end up with minus x equals minus 9. Technically what I'm doing here is I'm dividing by -1 on both sides, but I don't normally bother showing that. I just arrive at the answer x equals 9 by making them both positive. So we found x, which is great. Now what we need to do is we've also got an unknown angle. Now this is a bit tricky because we haven't practiced a lot of finding angles, and now we've got one that's got algebra in it as well, okay? So we're not going to freak out. What we're going to do is we're going to find the angle, and I'm going to just scrub all of my scratchings off this now so that we can switch over to trigonometry. I'm going to be very careful with my trig here. I've got this corner here, that's going to be my reference angle. I still know that this is my right angle. And the two sides that I'm going to choose to use are 20 and 29. I don't want to use more algebra, and I definitely don't want to accidentally make a mistake now that I've found 9 and all that. The other thing too is if I messed up my first step, then I'd be carrying an error. So I kind of get to freshly start all over again here. So let's go in for this one. I can see that this one's my adjacent, and I can see that this one's my hypotenuse. So if I run with SOHCAHTOA, I am going to use the cos rule because I've got an adjacent and I've got a hypotenuse. So let's start. I've got cos theta equals adjacent over hypotenuse. Let's fill in what we know. That means we've got cos 3b, or 3 beta probably, equals the adjacent over the hypotenuse. And then what we do is we rearrange this, and we're not going to panic about that 3b, and we don't get caught up in the algebra of it, anything like that. just leave it as 3b, just ignore it all the way till the end of the question, and then we'll just switch over to balance method and get rid of the 3, okay? So don't do anything fancy here. Remember that when we're finding an angle, it's going to be inverse cos, inverse cos 20 over 29. This thing's getting a bit hot and not writing very well, sorry. I'll try that again. 20 over 29. It's really not enjoying this. And then what we do is we pop that into our calculator and you'll get an answer, which I don't know what that is. Can anyone pop that into their calculator for me? Okay, so we've put that into our calculator, and then all we need to do now is we just need to work out what b is. So we're just going to switch back to balance method. So let's divide by 3 on both sides. And all we'll be left with is b, and that divided by 3, which I think works out to be about 15.47. And if we have units, sorry, it's degrees as well, sorry, because we're into an angle here. It's getting a bit squirrely. We're going to have to be a bit patient with it. It doesn't like... Oh, it is recording. We've noticed that we needed to add units to this one, so we'll just pop them in. This one was measured in meters. Moving on to the second question, we're going to need to use trigonometry twice. And so let's start by realizing that's the right angle there. And then we might target this angle to begin with. So that would make 6 the opposite, and that would make 14 the hypotenuse. So that means that I would use the sine rule this time, okay? So let's go in with the sine rule, and we're going to say sine, just chuck the angle in brackets so it doesn't fall apart on you. And by the way, these two symbols are different, okay? So we're going to have to run it twice. So, or are they both thetas? Well, they are both thetas according to the answer sheet. So let's run with that. So let's target this first one. And I've got sine and I've got that angle. That is going to be the opposite over the hypotenuse. And then what we'll do is we'll come in and say, great, that means that theta equals inverse sine 6 over 14. You don't need to simplify the fraction at this point because your calculator's about to do that for you and make life easy. We'll just pop that in our calculator. We've put that in our calculator and we're making sure we're still recording. And we've got 25.376. Now we're just balance methoding, so we're going to subtract 5 from both sides, and we'll find that theta is 20.38 degrees. And now we need to go looking for that omega sign. I'm not convinced that that and the theta are the same, so let's go looking for it just to make sure. We could do this in two ways. We could do this using trig again, or we could do angle sum of a triangle if you felt like doing that. I noticed on the answer sheet they're doing angle sum of the triangle, so you guys can do that one if you want. I'm going to run trig again because that way you guys get a little bit more practice at it, okay? So, or you get to watch me model it a couple more times. So this time if we go up and change this, and I'll swap colors to orange, I'm now using this as my reference angle. So now I've got an adjacent and I've got a hypotenuse. So that means this time I'll go back to using the cos rule. So I'm going to run with cos 4, and I think that's an omega sign, but it doesn't matter anyway. That will be the adjacent, which is 6 over the hypotenuse of 14. That means that 4 omega equals inverse cos 6 over 14, which if we put it in our calculators, we will find equals 64.6 2, 3. And then we're just swapping back to the balance method again. So I don't want to know what 4 of them is. I just want to know what 1 is. So we'll divide by 4 on both sides. Angle is going to be 16.16 degrees, and that question has been answered. So we know that those two symbols are different things and they have different values. In question 2, what we're getting is we're being asked questions about triangles that don't have right angles, so we have to be careful to make right angles. They've asked you to find the height of an equilateral triangle. You don't have to draw it, but you will definitely find that it's a little bit helpful in this topic if you can quickly do a sketch. It doesn't have to be. So what we'll do is we've drawn them up in advance. The first one's an equilateral triangle. That means there's a couple of things we know about this triangle. Every angle is going to be 60 degrees because equilateral triangles have 60-degree angles in every corner, and every length is going to be equal. Now that's a problem because it's not a right angle triangle. It has also told me that the perimeter, the distance around the whole thing, is 57 centimeters, which isn't very useful to me, quite frankly. I need to know maybe what one side is. So what I might do is I might say that one side is worth a third of 57, okay? If that doesn't make sense, what you could do is you could just divide 57 by 3 before you start so that you guys can work that out. And if you did that, you'd find out that each side is now 19, okay? So to find the sides, go 57 divided by 3, and that means that each side is now 19 centimeters, okay? We still don't have a right angle triangle to work with yet. So what we're going to do is we're going to make one. We're going to chop this triangle in half. And we'll later learn in Maths Extended, if you're in that this is actually going to form a special triangle, which we're going to learn about. But that means in this room here, that's a right angle triangle. And now what we need to do is we need to find the height of this triangle. And so we're back to a normal trigonometry question again now. So what we'll do is we'll say this is our reference angle. That makes this one the opposite and this one the hypotenuse. And according to SOHCAHTOA, I'm going to now use the sine rule because I've got a hypotenuse and an opposite. And now all I'm going to do is just sub it in and solve. So I've got, I've got sine theta equals the opposite on the hypotenuse. Sub in what you know. So sine 60 is going to equal x over 19. It's even a nice one. We don't even have to muck around too much with it. Let's multiply both sides by 19 to get that up. And you'll end up with 19 times sine 60 equaling x. And then it's just a case of popping it into your calculator, and you'll find that x is 16.45 centimeters. And that one's solved. So if you don't have a right angle triangle, the name of the game is to make one. Question 3 is pretty similar, except this time we've got an isosceles triangle, so it's not going to be quite as easy to work out the sides. We've got an isosceles triangle, so we know that the two lengths that I've put dashes on are the same length. We've got a base of 15 here, and we know that the overall perimeter is going to be 42, okay? So let's just say that we're going to call these sides y, okay? We know they're going to be the same. That would mean that if I had all the sides, so 2 of the y's added together and 15, I would have 42 centimeters as the total perimeter of the shape. So what I'm trying to do is I'm trying to work out basically what this length here is, okay? So we'll just use a little bit of balance method to get to the answer there. So, yeah, that's right. Yep. So what we'll do is we'll just do a balance method so that we're really nice and clear. We'll take 15 from both sides. And so what we'll end up with here is we'll end up with 2y, and on this side we'll have 27. Then we'll divide by 2 both sides. And so what we'll end up with over here is y is 13.5. So each of these sides over here, now we can give them a value. We know what y is. So this one's now 13.5 meters. And we've got the same problem that we had last time. We don't have a right angle triangle. So what we'll do is we'll make one. So let's chop this one in half, make a right angle triangle out of it. But this time it's not asking me for the height. It wants to know what the base angles are. So we'll call this one down here theta. Okay. You can use a letter if you want. We usually use Greek letters for the angles, and we usually use normal English letters for the sides. And this time we can use trig, but we will need to be using inverse rules because we're looking for an angle. Now, we still don't have our base here because we've got the total distance across the base being 15. So if we chop that in half, we know this one's going to be 7.5. Is everyone comfy with that? And then we'll name these sides up. So what do we got? I'm starting to run out of colours here. I've got an adjacent this time, and I've got a hypotenuse. So this time I'm going to use the cos rule instead. So we're going with cos, and we're going to go with cos theta equals the adjacent over the hypotenuse. Fill in what we know. We still don't know what the angle is. That's what we're hunting. Yeah. Yeah, it is. Yep, we got half of the base for the bottom because we've chopped the triangle in half. So it was originally 15 all the way across, but now it's 7.5. So that's okay. That's a good question. So what do we got? We've got the adjacent, which is now 7.5, and we've got the hypotenuse, which is 13.5. But I don't want cos theta, I want theta by itself. So theta is going to be inverse cos 7.5 over 13.5, which you guys can pop into your calculators, and you will find that the base angles are each 56.25 degrees. That's not a great looking 5. I'll just touch that up. And that one's solved. Let's roll on. Alrighty, this one is this one's going to be a long question. Okay, you'll get these ones. They'll be worth quite a few marks to you. And what you'll need to do is you'll need to use a combination of trigonometry and Pythagoras to get to the answer. Now, what you are welcome to do in this topic is you're allowed to throw in your own letters. Okay, so ultimately, I'm trying to find out what the length of this line is. That's the question. But you don't have enough information in that top triangle to do it. So we need to start down here in this corner, okay? So basically, if I go through this in steps, first I'm going to be finding this, then I'm going to be finding this, and then I can finally find this. So there's a fair bit of work to do here. If you have a look at that first question, I've got an angle on a side, so I need to use trigonometry. And what I'll do is I'll give this line here its own value. I'm going to call that line Y, and I'm going to call this one up here Z, because eventually I'm going to need it, okay? You can call it whatever letter you want. You can even make it a smiley face if you want. In the first instance, I'm going to have a look at that reference angle there of 22, and then I can see here that what I've got is if I go for red here, I've got an adjacent and I've got an opposite. Okay, so this one, if I go for SOHCAHTOA again, what rule am I going to use? Tan, excellent. So we're going to go for tan. So let's start that. We've got tan theta equals opposite over adjacent, which means that I've got tan 22. My opposite is y. My adjacent is 9. Balance method, let's get rid of that 9. So I'll end up with 9 times tan 22. And if we put that into our calculator, we will find that y is going to be 3.6362. Carry heaps of decimals in this, okay? If you round that down to 1 or 2 decimal places, you'll just start carrying too big an error through your question. So now that we've got a value for y, let's have a look at trying to find z. So now I'm looking at this triangle here. Here's my right angle. There was a right angle here and here, by the way. So this is the triangle that I'm up to now. Okay. This time I've only got sides. I don't have any angles, so we better switch to Pythagoras. And z is not the hypotenuse. So I'm going to lob in here with a squared equals c squared minus b squared. Okay, so we're going to call z, that one there is going to be the a, okay? So we've got z, we'll switch to blue. So we've got z squared equals 5 squared minus 3.6362 squared. We're rolling as many decimals as we possibly can here, and we're going to put that into our calculator so that we've got, z squared equals 11.7778. I'm still carrying heaps of decimals here. And then I'm going to stop. I know normally what I would do from here is I would square root this. But if I square root this and then I round it again, I'm just building and building the error. If that's what you've got to do, that's fine. Do that. But what I'll show you instead is, personally, I would just keep that number as it is and I'll keep using it. So now that I'm going for x, have a look at x. X is another one of these sides that's not the hypotenuse. I've only got sides to work with, so I'm going to have to go back to Pythagoras. So I'll just bring myself up here where I've got plenty of room. And I'm going to go for another a squared equals c squared minus b squared. And when I go and substitute this in, a becomes x, c is the 6, okay, so that's coming from over here on the hypotenuse. And then when I put in b squared, it just drops in as 11.7778, okay? I don't have to square it, because remember, it's already squared. Does that make sense? Yeah.
How did you know to stop at 11.77?
Because you see how over here, it's a good question. See how we've got z squared here equaling that? When I go and put it in place of b squared, because this number is already squared, it can just drop in exactly as it is, and it saves a little bit of the working out for me. So, and it also stops me from having this little error that just keeps creeping up and getting bigger and bigger, okay? So it becomes pretty helpful when you've got woodworking projects in your shed and stuff where the error keeps growing. So here we've got our x squared, and then we can solve what we can. We've got 36 minus 11.7778 here, and so we'll end up here with x squared equaling 24.7778. And then all we can do from here is jump back to the balance method. We'll square root both sides to finish up this question, and we'll end up with our unknown being 4.92. Well done. That's great. Don't forget your units. That was brilliant that you remembered your units. And we'll just make that really clear that the yellow here, okay, this is our final answer. In this question, question 5, we have got a question in a Pythagoras and Trigonometry unit, but this one has got a circle and an isosceles triangle in it. There are no right angles in this. So what we need to do is we need to make right angles. It's also given us a very limited amount of information, okay? It's telling me that the diameter is 20. And if you get a question like this, you're going to need to start with that, and you're going to need to try and work out what that means, okay? because this is obviously the key to answering this question. So if it has a diameter, that's the distance right across the circle through the middle of 20, that means that this line here must be 10. Okay? Now, if you have a look at this carefully, that means that if we'd completed this length here would have been 10 as well, but 6 of it's taken up with that dotted line. So that means that if we chop this triangle in half here, you're going to end up with a distance of 4 here. So we've actually got all the information that we need. So if we just move away from this for a second and we just draw this triangle over here, so we've got a nice clear right angle triangle to work with, we can start to fill in the information that we've got. So here we've got a right angle, here we've got a length of 4, here we've got a length of 10. Everything's in centimetres, by the way. And down in the corner, we have to be a little bit careful because it wants us to tell them what theta is, but we went and chopped theta in half. So this corner now is now theta divided by 2. It's half of what theta used to be. And from here, it's extremely similar to those first questions that we did. It's just basic trigonometry, but we need to be really careful not to get caught up with that theta divided by 2. We're just going to keep it together in brackets right from the start. Theta is the corner down the bottom. So you see it used to be over here, it used to be like the whole angle, but we chopped it in half. So that's why we're calling it theta divided by 2. Yeah. So let's begin as we always do. We've got our reference angle. This one's the opposite. This one's the hypotenuse. According to SOHCAHTOA, what rule are we going to use? Good. We're going to use sine. Excellent. So here we go. We've got sine theta equals opposite over hypotenuse. Let's fill in what we know. We've got sine, but it's theta divide by 2, and we're going to totally ignore that at the moment. We're just chasing the angle, and we'll get rid of that 2 later, okay? We've got the opposite of 4 over the hypotenuse of 10. I don't care about shrinking that fraction at this stage. What I am doing is I'm chasing an angle, so what I'm going to do is I'm going to use the inverse sine rule. So I've now got theta over 2 being equal to inverse sine 4 over 10, which we then need to turn to our calculators for. Well, we could actually move the 2 up first. That would make life a bit easier for us. So if we actually just times by 2 on both sides, we can do it all in one fell swoop on our calculator. So we'd have theta equals 2 times inverse sine 4 over 10. And by doing it that way, you can just type it into your calculator all in one go. Or you could do it in 2 steps, doesn't matter. But theta will be 47.16 degrees. And that has solved it for the full size angle, and that's the answer to this question.